Hey, LinkedIn fam, good morning, good morning. I am just walking on my way to the office. I saw a tweet the other day by Jason Lemkin asking a question, what in the world does the generative in generative AI mean? And I thought, that's actually a really good question. We've been using this phrase, throwing it around, and most people don't actually know why it's called generative AI. So while I'm walking, I thought I would break it down for you. Let's take it back. A little history lesson on the evolution of AI. Most AI that we've been using have all been about understanding information. Is this word a verb? Is it a special entity like a person, a place, or whatever? But for the first time with generative models, what we're seeing is AI that can actually produce new content. It can generate data. Now, generative models are built around a concept called large language models, or LLMs. The next time you're at a dinner party and somebody says LLM, you know what they're talking about. It is a large language model. Okay, what is a large language model? One of the baseline machine learning tasks for NLP is to construct what was called a language model. They didn't have the word large back then. What these language models would do is literally try to model a language. They would try to come up with a probability distribution that represents the likelihood of seeing certain words in a given text. You could use a language model as part of something that is really just scoring how good is this text. For example, if you see the words me go to the store versus you see the words I go to the store, this sentence, I go to the store, is actually a higher probability sentence of occurring in the English language than me go to the store. And so you would build these models out to literally just be able to score language. And then it got really cool and it got even more powerful. For example, given a set of words like I go to the blank, a language model would then predict what is the most likely next word, and it would assign a score to every single word, because again, all it's doing is figuring out a probability distribution at each point in time. So I go to the store, I go to the mall would be much more probable in the model than I go to the dog or I go to the cat. So words like store and home and locations in general would be scored higher than things that were not based on locations. And you could do this again and again for any sentence or any construction that you can think of. And second, we now have more powerful model architectures. You all saw I posted the other day about the transformer from this paper, Attention is All You Need. The transformer model absolutely changed the game. They used a simple mechanism called attention. And so instead of only looking at the past couple words to figure out, like I go to the, you could start to look at the rest of the context, the rest of the paragraph. And if eggs and rice were mentioned before in the sentence, then that would still increase the probability right now that you go to the store versus going to the house. So with these transformer-based models, we started to be able to build models that could take much more context and association into their probability distribution. These models are so powerful and so large. ChatGPT, or GPT 3.5, has over 175 billion parameters that it tweaks, and it was trained on over 500 billion tokens. Think about that. These models are so large that now they can not only just take text and produce a single word, but imagine if you took a prompt like, write me this new ad copy, or tell me about the French Revolution. Then it knows so much and is able to produce so much coherent text that it can not just produce one word, but it could produce 1,000 words that have high probability of appearing after that prompt, which then becomes a very coherent answer to the question. Now, there's a lot more to it than that, but that is actually the basis of large language models. They are language models that are literally built around predicting the likelihood of a word or something else occurring, but when taken and actually repeated, can actually be used to produce entire words or entire sentences by taking the most probable sentence from the probability model. And when you take that to the nth degree, you get GPT 3.5. All right, so anytime now you're at a dinner party and your friends ask, hey, have you heard about LLMs or large language models? You can answer, yes, I know exactly what they are and how they work. All right, signing off. I got to catch my train.